let's continue from where we left off. We were looking at ETL patterns. So the pattern that we will now discuss is something called as keys processing. So here it refers to actually a very specific set of concepts that we should all understand. So first and foremost, in the world of modeling data, there is this necessity to think about what makes data unique and how do you differentiate one data element from another. So primary key refers to a certain data element within a data source, which allows us to uniquely distinguish one data record from that data source from another. So much so that usually primary keys become these foundational constructs against which newer and newer data elements get created. So every time you do a CRUD operation, especially the C, the create portion of the CRUD operation, a new primary key gets generated. Updates and reads are invariably referring to those primary keys, and they use those primary keys as a way to do point deletions and point updates, and read could be using those primary keys as well. And when you model data this way, then because that data source or that table has those unique elements of data ordered based on a primary key, you could then use that guarantee of uniqueness to then add other references to those primary keys in other tables, which allows you to cross-reference an entire gamut of data without having to duplicate data sets all over again. So when you do that, you essentially build up what's called as a foreign key reference to this primary key. So let's take a look at both these in an example. I have my users table in my staging area within the OLAP technology, the data warehouse as an example. And the users table comes from some part of our business, right? Let's assume it's just basically a bunch of users that are registered with my website. The users table has 3 columns: user ID, username, and date of birth. So this format should be familiar to you now because it's exactly what a CSV file will look like. You've got your integers, you've got your data types, and you've got your strings and double quotes, right? All of these are comma separated. So this is your users table. If my domain of business where this users table is being created and updated and maintained, if that domain uses the user ID in a way that's unique, then automatically that can actually become the primary key for this table. So let's assume that's the case. So the user ID column is actually the primary key. Note that the domain could have reused user IDs for other users, especially after, let's say, for instance, these users have expired, new users have been onboarded, and the same user ID gets used. That could have been the case if the domain was not designed in a way that's careful. But if you design the domain carefully, you would not want to repeat user IDs come that way, in which case you build up this primary key concept in that particular column. Okay, so now let's assume you've got in the other line of your business the set of payments that have happened for different commerce goods. And here, the payment table is in staging. It has these different columns: user ID, item, payment amount, and payment time. Again, CSV. And here, the user ID is actually something that the domain captures as a reference back to the users table. So the users table is your primary table of source of information about the users in your system, and the payment table, which tracks who made payment for what and for which amount at what point in time. That payments table refers to the users table via the same user ID column. In which case, the creator of the user ID is not the payment process, it's some other process which is updating the users table, but the payment table refers to that standard ID, and by way of that reference, using this foreign key relationship to this primary key in the users table, anybody who looks at these two tables will understand it's Mr. 8 PDF Tulkanam bought his Apple iPhone on December 1st, 2022. Well, obviously, that's absurd. That's not true. But then, let's go with this hypothetical example. Alright, now we've taken a look at primary key, we've taken a look at foreign key. There is this notion of what's called as a composite key, which means at times you may not have a single column which is unique. So for instance, let's say that domain which captured the user information did make that mistake of, I shouldn't say mistake, but they did go down this road of regenerating or reusing user IDs after the expiry of an individual, then in which case they could still use a combination of user ID and date of birth to uniquely identify a specific individual, right? Because user ID by itself could refer to a person who no longer is alive or who is currently alive, as the case may be. Date of birth is also going to be unique to an individual, but there could be multiple date of births because multiple people could have been born on the same day, some of whom, could be sharing user IDs or not. But the way that you can uniquely identify would be a combination of user ID and the date of birth. In which case, the primary key is itself a composite key because you're composing two different data elements in your table to come together to bring about that primary relationship. So one of the implications of primary is that obviously the values cannot be null, right? So in determining, why is that the case? Because if it's null, then null is a special element, special value which denotes that there is no data for that particular customer in that particular column. So that's the case, then it's hard for you to say whether, in fact, tautologically, logically, you cannot say that that person has the same value as some other user ID or not, right? Because there is no data. It's not that there is data for you to say it's not that value. There is no data. That's what null refers to effectively. So, for a column to be a primary key column, it cannot be null. So obviously, uniqueness is also there. Now, when you think about a composite key, and you want to use a composite key as a primary key, this null check becomes like an important thing. Like what we just spoke about is user ID and date of birth combination is unique, fantastic. What if you don't have the date of birth for some individuals? In which case, that null check becomes that fails, right? Therefore, there would be scenarios where you would not be able to potentially reason about whether two different values for these two composite columns are the same or not. So keep that in mind. Alright, so let's take a look at now a third scenario, which is there is now a registrations table. And where is this table coming from? This coming from, let's say, the set of loyal users of this shop, of the retail shop. So we've got users table in this table. That users table comes from the domain of payments. And maybe that's just because at the time of payment, these users had to declare some things about themselves. But another part of the business is actively capturing registrations by way of encouraging loyalty. So these are loyal customers, they've signed up and they willingly share information about themselves in terms of email addresses and phone numbers and stuff like that. Here, the registrations software has been designed by somebody else who didn't design the payment software. So therefore, they used a very different nomenclature. So they used the word ID, name, email, and what's more, you start to see that the IDs actually start to look very similar to the users table that I've already captured from our payment system. So 123 repeats, 442 repeats, but guess what? The people are not the same, right? So here we're talking about residents in India. Here we're talking about residents in the UK. Prime ministers in the UK. Sorry. So in which case, the notion of user ID 123 referring to somebody specific is actually no longer correct, right? Because it refers to somebody specific in the specific context of payment, in the specific context of registration. But those two contexts are not the same. Those two contexts are different. They've been built by different systems, they've managed by different teams, and they have different databases in the back end. And the metadata also differs, right? It's not the same data that you collect about them. So in this setup, the ID column is the primary key. In fact, you might have some IDs which do not, have any equivalents here in the user's table and payments and vice versa. What do you do then? Right? So the problem statement when ETL applies, right, especially for creating a warehouse, is to actually create this integrated view of a particular part of the business. So in this case, let's say integrated set of customers, users. So in order for me to create that integrated users table, I need users from both sides to contribute. But when users from both sides contribute, they have their own representations of data. They have potentially overlapping definitions of the same data element, right? In this case, the user ID is 1, 2, 3, and 4, 4, 2. So in which case, what I then need to use would be a separate key which cannot be the same as the primary key of the respective sources. Because the moment I use the primary key of one source, I'm automatically discriminating against the primary key of another source. So I need some other ways to map these primary keys if this primary key gets used and vice versa. And that becomes like a completely different complex problem. Instead, one of the classical ways to approach this is by introducing what's called as a surrogate key, which then becomes your primary key. And that surrogate key is generated afresh by your system as part of the ETL pattern, and which nobody else has access to, right? Meaning, nobody else can take that up and start to invent their own logic, because then that will throw the consistency out of the door, right? And more importantly, you then form an abstraction, which is basically a separate key, which is completely not affected by whatever the different source systems plan to do for themselves later on, right? So, meaning the user's table and payments, that system might evolve, might take its own direction, right, over a period of time. They start to maybe use ASCII characters, not just numbers, to model user ID. Whereas the registrations table, they might choose to sunset the system, open up a new system which has like 15 other columns. Doesn't matter. The surrogate key abstracts away those details and makes sure that if at all the source systems do change, what ends up changing in the ETL pattern is the pipeline that leads up to the surrogate key on both sides, as the case may be. But when the final integrated view of the users is built up, the surrogate key becomes the primary key, and the surrogate key becomes the only way in which those users are referred to. And that becomes very advantageous. Then you get to know that. Then you truly rationalize the set of users. You don't worry about it. Their residents of India, prime ministers of the UK, etc. So, surrogate key calculation is a very key ETL pattern. You'll find it all the time. So, one of the ways in which I've gotten pushback at times from other big data platforms that get built out in practice is, why do we need to go through this elaborate key management process? Why can't it just integrate data? Why can't it just join, as the case may be, last minute without going through this process of integration? So, join last minute, figure out what you need, go ship the answer, you're done, right? And that's kind of going back to this old problem statement I was talking about, which is finance wants something done, so they do their own joins and they get their answers. But business wants to do their own thing, they do their own joins and they get their answers. The two answers are not the same, but they're supposed to be talking about the same thing, right? So that inconsistency in view comes about. But I think the more critical way to look at that question or that objection is to say the deferment of quality of data invariably is detrimental to what you want to guarantee as standard representations of data, because if you don't give the guarantee, it's very hard for business to take a call. So if you keep deferring the quality assessment of the data, then you get to a point that the person who's actually interpreting the data will also have to interpret the quality and make a judgment call about how to deal with that quality. Like in this case of this integrated user. So if that didn't exist, and if somebody really came in and said, okay, look, I need to send emails, and I need to send emails to every user who's paid at least 1,000 rupees for the last 2 years. Do I pick up users from the registrations table? Yes, because that's where the email IDs are. Do I pick up users from the payments table? Yes, that's how the payment table is foreign keyed on, right? And I need to understand the payment amount. But can I just do a join between the user tables? No. The 1 to 3 user ID is not the same. I could still do the join, I could still get an answer, but the answer is invalid. Right? Abdul Kalam is not Margaret Thatcher. So, what happens then, right? You effectively defer the problem of quality to the hands of that marketing individual who's taking the call to send emails. Then, what he or she could be doing, they could be doing two things. One, they take a look at this table and say, wait, 1 to 3 is actually not the same thing. I can't make these two individuals are not the same. And they could alert saying that, look, this quality issue is a bigger issue. They can't solve it, right? Because they can't just say Abdul Kalam's email ID is empty at Yahoo.in, right? That doesn't make sense. Or they could be doing the other thing, which is run a join. Join users table for payments on user ID. Equal join with users table for registrations on ID. And I do get a valid email address. I am going to send the email. And the email is going to go to Margaret Thatcher, addressing her as Abdul Kalam. So, in deferring, you've really made the choice to be exercised at the hands of somebody who's not equipped to actually deal with that. And that's far more dangerous for the business. Right? So, that will be my counter argument to that whenever somebody makes those kinds of objections. Deal with it up front. Deal with it in a way that's integrated. And the best way to deal with it is right at the point when you construct these layers of data in the overlap system. Alright. So the next pattern that we will going to look at is actually a pattern which is related to keys processing. This is called as master data management or reference data management. Now, this is an entire topic in itself. Many layers of complexity here. There are again dedicated tools that have come about which deal with this. Some of them call themselves data catalogs. Effectively, they are metadata catalogs, really. Some of them call themselves master data management tools or MDM tools. Doesn't matter, right? Ultimately, you're dealing with the ability to take in reference data from other sources beyond your standard data sources and then deal with variations because the nature of reference data is such. Okay, let's take an example. We'll use the same example of shopping items, iPhones and stuff like that. So, one of the classic ways in which reference data gets generated and gets shared with platforms is Excel files. Because guess what? It's humans who actually produce these, not machines. So, there's some kind of product manager or a business manager who goes about saying, look, I'm going to catalog all the things that I'm going to sell as a business. I'm going to put it all in an Excel file, circulate it amongst my peers, my manager, get it ratified, get it verified. So, okay, yeah, I have all these kitty. So then finally the Excel file gets used and then gets handed over to the business team or the data team. And then the data team has to then reconcile that particular Excel file with all these payments information that come in a real-time sense. And this happens even with the biggest of the most modern of companies as well, by the way. Right? So Excel itself is not taboo. It's a very common pattern. Yeah, so reference data could come into other sources, right? For instance, the Excel files could be produced by none of your employees, could be produced by third-party brokers, could be produced by the stock market, could be produced by some other partner company that we work with. So many different ways. Reference data could come through APIs, could come through databases, could come through messages, could come through emails. Again, a lot of different ways in which this gets generated. Some of the reference data sets are very small, like for instance the days of a week. That's a reference data, right? There is absolutely no change in that. The holidays in a week, right? Meaning the weekend holidays. That can change based on which country you are. In the Middle East, it's Friday and Saturday, right? In the Western world, it's Saturdays and Sundays. In some of the parts of the world, it's something else, right? Likewise, the business hours for a particular business could change, like it not be 9 to 5, could be the midnight businesses, could be 24 hours. All of that is reference data. Okay, so let's take a look again at the payment table that's become a friend now from the previous example. Same payment data. Here, what happens if you now see payment information for an item that does not exist in your Excel file of products? So again, winding up domain is such that payments is getting collected in a payment table. Separately, the payment is actually being mapped to users. We saw that in the previous example. The payment is also actually being mapped to the product, right? Which product is being bought. And that product is being certified by a bunch of product managers who then certify and verify and send you this final Excel files, right, of what products are there, which category the products belong to. So Apple iPhone is a smartphone, Samsung is a smartphone. But that Excel file that was given to you as a final product master list did not have Nokia E340. What do you do then? Okay, in reality, what could have happened here is the fact that that product genuinely existed and the product manager listed it. Right? That could have happened. What's also equally possible is the product does not exist and there was an act of misclassification on the part of whoever is preparing the inventory for sale. That could have happened. Third scenario that could have happened is the data that's being collected at the payment system could genuinely have issues with respect to cross-referencing. So the master data that the product team gave you as a data platform builder, as a data engineer, could be the same that they gave to the payment system as well, but the payment system used a different version of an Excel file. Maybe the previous version of the Excel file actually had this product, whereas the newer version, which is supposed to be used, did not get updated yet in the payment system. Or the fourth scenario that could be possible is the other way around, right? You've gotten a version of the Excel file, which is no longer true, no longer the reality. The latest version of the Excel file of products, the master product list, has already been circulated to the payment system because that's the critical system. That's what drives your business. That's what collects the money. But you, as a data engineer building a Ola platform, you're treated like a second-class citizen, right? You're not actually given that data in real time or refreshed adequately fast. In which case, you're dealing with an older version of the product master list. The newer version is already there. The newer version is getting recorded, and the payments are getting logged against those items. All four of these scenarios are possible. What do you do then in this scenario? Right? When you do get this data, the data refers to something that does not exist. The easiest thing to do is just to ignore this record. Is to say, look, the user IDs are mapping, fine, the primary foreign key relationship works as well. The item foreign key relationship, that's my, or rather the item lookup to my reference data of the master product list does not have this item. I don't recognize this payment, I'm going to drop this record. That's the easiest thing to do, but that's potentially the worst thing to do. Because you have lost data intentionally. Right? What's better, right, is to actually start to think about, can I make a placeholder entry? Maybe there's a mistake in one of the data processes that is giving me this latest set of data. Like the fourth slide I was talking about, right? Maybe product manager will share with us the latest version. So I make an entry, I make the payments recorded here, I give the consolidated view of payments for all items, including this item that does not exist in my reference data. But then I point it out. I point out saying, look, this did not exist, but I'm still recording it. That might be a better way to do it. There could be, for instance, another scenario that comes in. Here, the data itself could be organized in a completely different fashion. Right? So the reference data initially said categories and products, right? And that's how it came to you. And then you've gone ahead and built an ETL pattern, joining it with payments, right? And you've also said, yeah, for items that I don't recognize but that exists in the payment table, which means the payment was made successfully, I'm just going to make an entry that says that, look, I don't have this corresponding version in the reference data. But you go past all of that, and then you alert, and then the product manager says, hey, I made a mistake, sorry, I'll give you a new version. And in the new version, they don't call products as products anymore, they call it as items. Right? So that then produces a reference data, which is completely different from what you just used. How do you deal with it? Right? So now the joins that you do, or the lookups that you do, that version, that name does not apply anymore. Or what also is possible is that the descriptions could change. Right? You just had here Samsung Galaxy as an example. In the newer versions, they've started to work out different versions of Galaxy S4, S5, S6, etc. So then when you get a payment information that says Samsung Galaxy, what do you map it to? Do you map it to S4, do you map it to S5, do you map it to S6? So these are all very real world problems, right? When somebody says, rather, when you go through data science courses, you see the data preparation is all the time that you spend. Part of the reason why that's the case is exactly to solve these kinds of problems. And there is no right technical answer for how to solve these problems, right? There is actually every element of business that needs to be involved to actually give you the right answer. So when Samsung Galaxy gets mapped to S4, somebody somewhere else is getting impacted as a result of the business, right? The person who is incentivized to sell S5, as an example. All the credit that needs to go to him is actually going to S4. And that's detrimental to his life. So it's not just a technical decision, it's actually a business decision. But then if you have patterns to deal with it, you can deal with it in a way that's scalable. That's the point I'm making here. Alright, so the way again to solve these kinds of issues is by introducing an abstraction of what's called as a reference key. The reference key becomes like this generic way of organizing reference data using, potentially even naming conventions which have no meaning in real life, right? Like for instance, when we see user ID 123, we don't really know it's Abdul Kalam, we don't really know it's Margaret Thatcher. But it is 123 and it's easy for us to understand. It's easy for the machine to just record it and move on. Likewise, instead of modeling items in terms of the descriptions and in terms of the name, we can actually choose to model it based on a reference key. So the source systems cannot be changed, of course. At the point of constructing the warehouse, the source is already collected the data. But in the data warehouse, I map every single item that I know uniquely to a reference key, and I use the reference key as the way to record events like the payment information. So in my payment information in the intermediate layer, I'm going to get Nokia 340 replaced by item ID 5678 as an example, right? So then the fact that Nokia 340 is pertaining to 5678 is a particular mapping that gets stored in the reference table that I'm creating as part of the ETL pattern. So any new versions of the reference data, any new versions of each of these different references will all go through the same reference key process, and as a result be subject to the same abstraction. So then I don't need to worry about missing references because I'll just create a reference key, keep the item open, and then wait for the reference data to catch up. That's one scenario. Another scenario, so I might already have the latest versions, but the payment information does not reflect those newer items that I've added, which is okay. Again, reference keys exist, but they don't get used. So this abstraction again allows me to decouple what happens in the source systems from how I want to deal with it for the business to consume. Very similar concept to surrogate key, but here I'm actually creating a brand new key, which is necessary for me to deal with reference data separately. Alright, so we've taken a look at two critical patterns in this video. In the next video, we'll take a look at some additional